Hey, televisions, back with me again, Aji Gautama Putrada. I am your lecturer for operating systems. This is the eighth meeting about memory management, and in the fourth video, we are talking about paging. So let's do a little recap again. We have discussed about partitioning, and let's just assume that there are two types. First is fixed partitioning, and the second one is dynamic. And there are each has its problems. Fixed partitioning has a problem called internal fragmentation. And dynamic has external fragmentation. And so we have a solution for internal fragmentation, which is called paging. And this is what we are going to discuss now. Yeah, so we are back in our example of fixed partitioning, which before we have the problem of internal fragmentation, but here we have a solution that is paging. So how is this? How does it work? For example, like we said earlier, we have a process which is the size of sorry, we have the process with the size of 5 mega, and we have another one with the size of 4 mega, and so the 5 mega goes here and it leaves 3 megabytes here, and the 4 mega should couldn't go into this gap, so it goes to the second partition. But now the solution is paging. And how does paging work? Paging divides every process into smaller pieces of sub-processes, which are called pages. So for example, we determine that one page has the size of 1 mega. So this process here has 5 pages. So we divide it into 5, 2, 3. Okay, this is ugly, but just believe it's 5. And then this means that the second process has 4. 1, 2, 3, 4. And now that it's in smaller pieces, it can fit into smaller gaps. So here, 5 of them goes here. 5 of process 1 goes here. And although we have a gap of 3 megas, we can put 3 segments of the second process here. So 3 of them goes here, and then we can enter one of them in another partition. So that solves our problem. The next problem is how to address those pages. So in this other example here, we can see that there are many processes here. There is A, there is B, and there is C, and there is D, and each of them are divided into fixed size of pages. Here A has 4 pages, and B has 3, and C has 4, and then D has 3. And all of them enter a main memory in a certain address. So we have to know which partition is in which memory address. So now we have a sort of table, and this table maps the partition number to the memory address. For example, in process A, we have partition number 0, 1, 2, 3. 0 is in memory address 0, and 1 is in 1, and 2 is in 2, and 3 is in 3. But in process C, we can see, haha, that process 0, 1, 2, page 0, 1, 2, 3 are in 0 is in 7, 1 is in 8, 2 is in 9, and so on. And lastly, we can see in D here 0 is in 4, of 0 of D is in 4, and 1 of D is in 5. So keeping track of that needs another effort, and we'll learn that in the next video.